Swifters, it's Prof G, and it's time to ace that API access as if you were Ash Ketchum or Misty. To do this, we're going to use URLSession and Swift's built-in JSON parsing features to call the Pokemon API and catch the first page of creatures. Let's learn big! So if you followed the earlier lesson, you've got a basic list of placeholder data Pokemon, but we don't want the creatures that we entered into our app. We want to get the data over the internet from the Pokemon database. So to do this, we'll create a custom class that will make an API call to access data over the internet, then parse out or extract just the data that we want. We'll put that data into custom data structures, and we'll use those to display in our interface. So we'll head to the File menu and select New, File from Template, Swift file, not SwiftUI view, and we'll call this class Creatures with a capital C. So we're going to create a class in here by stating class Creatures, capital C, because class is a data type, and open and close curlies. But before we add any more code to this class, I want to show you the JSON and talk through how we're going to make our API call. So we're going to use Swift to parse or filter or extract just the JSON data that we need. This here shows the top part of the JSON that you'd see in a browser if you access the Poke API at the URL pokeapi.co/api/v2/Pokemon. Now JSON is organized in key value pairs, with the keys and values separated by colons. This is similar to dictionary types if you know what that is, but if not, the key is the name of the data, while the value is the data itself. Now for starters, we're only going to extract a bit of the data just to confirm our API call and the code that we're writing to extract the data is working. So we're going to get data from the count key, this number here, and the next key, which is this string here that contains a URL that we'll use to get the next page of Pokemon in a future lesson. Now we'll eventually get the results of the array of Pokemon down here, but we'll start out with just these two values to make sure that things are working. Accessing this Pokemon data down here is just a smidge more complex, and when learning, I think it's always good to work in stages, one smaller step at a time. Now we're going to use a SwiftUI object called URLSession, which is going to get the JSON for us, but once we have that JSON, we're going to need to parse out the data into our own variables. So we're going to need to create a structure that matches the JSON that we want. This is going to, in a sense, create a sort of data container that we can pour the JSON into. And Swift makes this super easy. As long as we create a structure that conforms to Codable, and we'll simply add a colon with Codable after the class name, and has properties that match the key names, the names have to match exactly, same spelling and case, and each property or variable holds data of the same type as the JSON, so this is an int and this is a string, then Swift will let us pour this JSON into the custom data structures, getting just the data that we want. Once we have the data structure set up, Swift has a special object called JSON Decoder, which does most of the work for us. Cool. Now remember, the key names need to match the struct's properties, these variables. Now I could have called the struct itself, the returned up here, any valid struct name, but I like capital R returned, so I often use that in the apps that I create. So this is how we create a container to hold the JSON, but how do we actually get that JSON from over the internet? Well, these are the steps. And we'll put these steps in a function that's going to be pretty reusable. Now, this is what we're going to do. We're going to write a function called getData. We could call this function anything, but I like the name getData. And we need to do something that we've not done before. We need to mark the function with the async keyword just before its opening curly. Now, this means that the function is an asynchronous function. It'll run, and the rest of the code doesn't have to wait around for the results to be returned. Your app will still function so it won't look like it's frozen. Now, this is important when accessing the internet because sometimes accessing data over the internet is noticeably slow, and we don't want the app to freeze otherwise while we're waiting for the results to come back. So asynchronous functions are marked with the async keyword, and they don't cause the rest of the app to freeze or wait. The app continues to function, but when the results come back, the app will perform the rest of the code in this function. Next, we need to create a URL that we can use to access our data. Now, I like to use the value named URL string, which is a string, but what's important here is we need to convert this to a special URL type that Apple needs. Swift can't make an API call with a string. So we use the guard statement to try to convert the string to a URL. If it doesn't work, we print out an error and return, but if this works, we've got this URL set up in a constant called URL. Now this line up here prints the URL that I'm going to be using in this API call with a spider web in front of it. This can be super useful when debugging JSON in your app because if you run into a problem and you want to find out the last URL that you used when making an API call, you could just look in the console for the last web emoji that prints out, and you can copy the URL that comes after that, then paste it in the browser, take a look at the results you were supposed to get back, and compare that with your code. Then we'll call URLSession, passing in the URL that we just created. Now URLSession is a special class that we'll use to to handle getting JSON data over the internet. It returns data from over the web, and it returns a response, which is usually a status code that reports if the call worked or not, and it'll also throw an error if we have a problem with the URL session. Now in this case, it'll either work and we'll get data, or we'll throw an error, so I'm going to ignore the response value in here. That's why I have an underscore. This also looks a little strange here because you can see that we're getting two values back inside of parentheses here. Swift calls this a tuple. Tuples are pretty common in programming languages. It's a result that can actually contain multiple parts in here. We've got data and response even though we're only using data. Now another thing to know about URL session is to get data like this, it can throw an error, so we put the try keyword out front, and we're inside a do catch clause, so we're covered for that. But this function also runs asynchronously. This is the reason that we needed to put async up here in the function declaration. So Swift requires us to put another keyword, await, in front of URL session, just after try. Now, if we forgot to do this, and we'll deliberately forget to do this when we're writing our code, Xcode is going to demand that we add this in, it'll offer to fix it for us, and I'm going to both forget the await keyword and the async keyword in the function so you can see how that'll work. Again, we got a lot going on here, but we'll see it in action in just a bit. Now, once we have the data, we decode it using a JSON decoder. Now remember that returned is the name of the struct that matches the JSON key value pairs we want to access. We talked about creating that in the previous slide, so we need to refer to it here with the .self term after it. And the from value here is data that we got from our URL session that contains the JSON. So this is going to decode the JSON. It's inside of a guard statement, so we're going to print an error if it doesn't work. Otherwise, we're going to have decoded the JSON into the variables in a return struct, and we'll have that data inside of a constant called lowercase returned. Now, if this works out, all I'm going to do is print out the count and the next properties of that returned constant, but if this fails, we'll catch and print out an error. Now again, this code looks kind of gnarly for the beginner, but it's very reusable. So if you have a structure called returned with a capital R, and you pass in the URL for your API as a string called URLString, for basic API access, the only thing that's different is this line here that prints out the two values that are specific to the Pokemon API. Cut out that line, and you've got a reusable starter chunk of code that you can customize as you need it. So let's code this up and see if we can get some data. So now let's enter the code we just looked at. We'll add our getData method with func, getData, open and close parens, open and close curlies. Now I'm not going to add something that we need in here, our async keyword just before the open curly. I want to show you the errors that you'll get if you forget this, so I'm deliberately leaving it out right now. Now, our first step is to get the URL. And as I mentioned, I like to pass this in using a variable called URLString. And even before I convert the string to a URL type, I like to print out the URL that we're accessing. Again, this can be really useful. If you get an error when you're running your getData method, you can just look in the console at the last URL it prints out, copy that, paste it in the browser, and then compare that with what you were expecting to work with in your code. So to do this, I'm going to say print, and in between double quotes, web emoji, since we're accessing data over the web, followed by we are accessing the URL string interp. And what do we put in the string interp? Well, I usually standardize on using a variable called URLString that holds the string that we will eventually convert to a URL. So up here, I'm going to add a property var URLString equals double quotes, and then to make sure that I have the exact URL, I'm going to head over to the browser, and I'm going to copy the URL that shows the first page of JSON that I want to access. Now this is the same URL that we had showed earlier in this lesson. It's pokeapi.co/api/v2/Pokemon, all lowercase. And then I'm going to return to Xcode. I'm going to paste it in between quotes, add URLString to the string interp in my print statement, and that's it. Next, Apple needs to convert the URL string to a URL type. Now, this might fail, so in case it returns nil, we'll use a guard let statement to guard against the nil with guard let URL equals capital URL, open parens, select the option with string, pass in URL string, else, open and close curlies, return, and above the return, we'll print out that an error occurred just so that we can see this in the console if we run into problems when we're building our app. So we will print angry emoji, so any error is easy to find in the console. Error, could not create a URL from string interp, and pass in URL string. Now, once we have the URL, we're going to make our call to URLSession's shared data method. Now, this method could throw an error, so we're going to do this inside of a do-catch clause like this. And when we try to get data using URLSession, it can give us back a tuple. Now, some folks call that tuple. I say both, don't at me. And that has a data value and a URL result. So we'll start this by saying let, and in between parens, the two values we'll get back. We only care about the data, so I'm going to say lowercase data, which is actually of type capital D data. And if we cared about the response, we could say comma and give it a name like response in here. But frankly, we don't care about response in this app, so I'm just going to put an underscore in for the second part of the tuple. If you ever write a more advanced API access in the future where you really want to take a look at this response, you could just call it whatever you want in here. Response is a good name. Then we set this tuple equal to try, and we need the keyword await in here, but I'm going to deliberately leave this off so that you can see what kind of error occurs. And then we'll add URLSession.shared, then .data, select the option from URL. Now this throws, but we took care of that with our do, catch, and our try, but it's also async, and this is going to give us an error, but we'll let Xcode fix that. Make sure you pass lowercase URL in for the URL, and we see a red error ball down below. Now the reason this shows up is because I didn't include the async keyword in the function definition line. It should be right after the closing paren. Now if we click fix, our buddy Xcode will add that. You see that right up here. But the error ball is still there. It says the expression async is not marked with await. So async on the function goes hand in hand with await. That's on any function or method that's asynchronous. So let's click on the fix here, and Xcode, superior tool that it is, adds the await keyword in between try and URL session. Nice. Now, before we can do anything else with the data that we got back, let's print the error message in the catch clause. I'm just going to copy the error message from above, paste it into the catch, and I'll change the catch error to read, could not get data from URL string. And now we have data back from URL session. We want to decode this data value, which contains JSON, into our own data structures. But we haven't created our data structures yet. Well, let's do that now. And as we pointed out earlier, since we want our count and next values, and those are at the very base level, we need to create a data structure that matches what we see on the web page so that the JSON can in effect be poured or decoded directly into matching data containers that we create. So we need a count value that is an int and a next value that's a string. Although I'll eventually point out that this string here actually needs to be an optional string. And not to get too far ahead of ourselves, but you see how previous is null here? Well, if I clicked on this, it would go to the previous page of Pokemon. But since there's no previous page, since this is the first page, that's why it says null. Null is JSON speak for nil in Swift. Well, eventually we're going to get page after page of Pokemon, and when we get to the very last page of Pokemon, this next value is going to be null too. Now, I'm not going to create our next value as an optional string yet. I want us to see the error in a later lesson. I think that's going to be useful because not realizing that your data can contain a nil or null value is a very common thing to experience when decoding JSON in Swift. So if you see that now, hopefully if you encounter this later on in your career, and I'm sure you will, you'll know what to do. So to back out a little bit, let's go ahead and create this struct. I'm going to put that right under the class definition. I'm going to say private struct, name this capital R returned. Very important, since we're using this to decode JSON, you want to say :Codable, conform to the Codable protocol, open and close parens. Then inside the struct, we want to create a data container that's identical to the key value pairs that we want to retrieve. So inside here, I'll say var count:"int and var next:"string with a comment that says to do, we want to change this to an optional, but I'll demo why later. And so now that we've got a container that matches our JSON, why don't we pour some JSON into it? So our JSON data is inside our value named data, which we got back from URL session in the tuple up here. And I say pour, but what we really need to do is decode this JSON into our return data structure. So in the do clause here, after we get the data and response tuple, we'll say guard let lowercase returned, and I could call this anything in here, but a lowercase version of the uppercase struct name is the convention that I want to keep, and we're about to decode the capital R return struct, and we'll set this equal to try ? And remember, the try question mark here just means that if we throw an error, we'll just return nil. We'll ignore the error. Then we say JSON decoder, open and close paren, so that creates the decoder in here. Make sure it's a DE coder. And we'll say dot, calling decode, and this wants the type and the data that we're decoding from. So press return to accept this, and we pass in the type the same way we did in to-do list. So the name of our type, in our case here, this is capital R returned, followed by dot self. And then for the value, we just put in lowercase data, which again is this value that we got from the tuple. And now I've got to end guard with an else, open and close curlies, put return in between, and I'll copy my error statement from down here, and I'm going to paste it above that return statement, and I'm going to change this to read JSON error could not decode returned JSON data, and then just below this, just to confirm that our JSON is decoding properly, I'm going to print out JSON returned, count string interp, and in the first string interp, I'm going to put in returned.count. Then after that, I'll say comma next colon string interp, passing in return.next. And I think this is very cool, so I'm going to put a cool emoji in front of this text. That'll also help so that I can find it easier in the console. And there's just one more thing we want to do with our class. We're going to go above the class definition, and we're going to add another Swift macro. Remember, we work with macros with @model when we were working with Swift data. Well, here we're going to add @observable. Now, this is going to have our code constantly watch any objects created from this class. If we also add @state in front of the value declaration, and if that value in that object changes, it'll trigger SwiftUI to redraw the user interface just like a regular state variable. Now, this is a fairly recent addition to SwiftUI. It used to be much more complex and far less efficient to try to watch for data changes. Now, all we need to do is add the @observable macro. We'll do that in any class where we're going to create objects where we want to watch the data for changes and trigger a user interface redraw. And if you wonder why Swift data behave this way without us declaring things as observable, well, Swift data conforms to observable without us having to do anything explicit. We get observable for free automatically with Swift data. We've got to add it otherwise. So now that we've created our creatures class and our getData function in that class, let's use this to create an object in our creatures list view, then use that object to call its getData method, and we should see some data retrieved from the web. And right now, we won't do anything with the JSON that we get back. We just want to make sure that the results print to the console properly. Then once we verify this works, we can go back and modify the view model so that we can get more data, including that initial array of 20 Pokemon creatures. So to call getData, we've got some work to do in our creatures list view. So let's head over to that file. And remember, we created this string array of creature names, but that was just to create our layout. We're going to replace this with an object created by our custom class that's related to the JSON that we saw in the browser. Now I want to call our new object creatures as well. Now we're already using the term creatures, so for now, just to save some time, I'm going to comment out everything in this list view by highlighting it and command /. I'm going to want to modify that code later, but we'll leave it commented out for now. And then we need something in our navigation stack so we don't get an error, so I'll just put a text view up here with the string literal, come back and fix this, to do comment, uncomment below. Now I'm doing this because I no longer want creatures to be a string array like we have here, so let's comment this out, and above this I'm going to say var creatures equals capital C creatures, that's our class, open and close parens. Remember, that initializes a new object using the class like a blueprint, and this object, lowercase creatures, has everything in the class, including the getData function, which is going to get our data. So now we want to call that getData function asynchronously. We don't want to hold up our app. And we also want to do this when the app first loads. So I'm going to use a modifier down below the navigation stack that acts just like onAppear, which we've used previously, but this one is called .task. Now that's going to also execute when the view first appears, but it's going to run any code inside of it asynchronously. Again, that means it's not going to hold up the rest of the app, so you'd still be able to tap around your app. It won't look like it's frozen, but it's going to try to get the data behind the scenes, and then when it gets the data, we can deal with any changes in our UI. But I got to make sure that I change my creatures variable to an @state variable. So inside the curlies of task, I'm going to say lowercase creatures dot get data, and look at that. I have the keyword async in code completion here. Now I don't have that inside of the task because this automatically lets me execute asynchronous code. So we don't need to add async to task. I'm just going to press return to accept this. I am going to get an error though, because when I have an async function, I still need a keyword in front. Do you remember that keyword? Well, if you don't, your buddy Xcode will help you out. It says it isn't marked with await. Oh yeah, that's the keyword. Click fix. Await is added in front just where it should be, and now this should work, and it does. It used to be that you had to run this in the simulator to see results, but now we can just open up the debug console and hey, I see some stuff down here that's printed out. Now let's get a look at this from scratch as if the app were to run brand new. So I'm going to click on the console and click Command K to clear out the console, and then I'm going to click the live play button in the preview pane. That'll rerun my code, and I can see the web emoji and this line saying that the URL is being accessed. That's the URL that we put into our creatures class. Then we see the cool emoji, which we put in after our data was successfully accessed. It says count is 1302. And by the way, the Pokemon Corporation is constantly adding Pokemon, so there is a chance that your number here might be larger. And after this, in the same line, we also see next, which is the URL that it got from the web. None of this was hard-coded. It must have come from over the internet, and to check this, we can copy the URL next to the spiderweb line, head over to the browser. This is actually the data that we're looking at, but we can paste that URL up in the browser again to refresh the screen, and we see indeed count is 1302, and next is the same URL that we saw printed out down below in Xcode. Outstanding! And if you want, you can build and run in the simulator, and you'll see the same sorts of results down in the debug area. Nice. So congratulations, Swifter. You just made an API call, and you parsed some of the JSON you got back. And before I forget, I'm going to put @state in front of my creatures variable up here because I do want any changes to creatures to trigger redrawing of the user interface, and we'll see that in action in just a bit. Now, let's up our game and get that first page of 20 Pokemon so that we can display it in our list. So let's head back to the creatures class, and we'll modify this class so that we can get more of the JSON data. Now, before I change the struct, I'm going to create a variable to hold count with var count equals 0. And now down here in the do catch clause of my get data function, I'm going to highlight and delete the line where I printed out the cool emoji, and instead, I'm going to load up my class properties like this. Self.count equals return.count and self.urlstring equals return.next. So back to the top of the class, we need to make some additional modifications so that we can get an array of Pokemon. Now, if we look back at the JSON that we want to access, we see that all the Pokemon are inside the results key. Now, after the colon, it's not a value like string or number. Instead, we see an open square bracket that indicates that this is an array. And the curly separated by commas show each element in the array. And each element between the curlies shows a name string key value pair and a URL string key value pair. And this continues down. See, name URL, name URL, name URL. That's because this is an array. So we want this. So we need to make sure that our first struct that we get, which is, remember, our return struct, which already has properties for count and next, will also have a property for results, spelled the same way in lowercase letters, just like this key. And this results should be an array of a new struct that we need to create that has a name property and a URL property inside of it. Now, it doesn't matter what we call the struct, but I figured we'd call it result singular, since we're getting an array in this key here, which is results plural. So let's head to our class and create this. So I'll start out with private, and you'll see in a bit that I actually shouldn't use private at this level, since I'll need to refer to this struct in other parts of my code. Struct, capital R result, colon codable, very important. If it's not codable, then we can't use it for decoding JSON, so make sure codable is in here for anything that you use in decoding. Open and close curlies, then inside the curlies, var name colon string, var URL colon string. This URL, by the way, is going to be for accessing detail on each Pokemon. We'll use that in a future lesson. And now we need to modify our return struct above. We'll add a var results. Now remember, it's got to be spelled exactly the same way, the same cases we see in our JSON in the browser, colon, and in between square brackets, result capital R, since this is an array of the new result struct that we just created. And so now below, I want to create another class property, a variable, to hold an array of this new result type. This is going to hold the Pokemon that we get from the JSON and parse out so that we can display it in our list. So I'm going to say var, I'll call this creatures array, and I'll set this to an empty result array with colon, bracket, capital R result, close bracket, equals, empty square brackets, and I'm getting an error in here. And this is because I declared the result struct as a private struct. So, aha, since I'm using this struct in a variable that's going to be visible outside of this class file. I need to remove private because private restricts this struct so that it's only visible inside this class. Once I get rid of private from in front of result here, the error goes away. Then, down where I decode my JSON, I'm going to add a new variable here as part of the decoding. I'll say self.creaturesArray, and notice code completion says creaturesArray is of type an array of result structs, equals returned.results, and look at this. The results property of return is also an array of result type. Since they're both the same type, we can set these guys equal to each other. That's all we need to do to get those Pokemon. So now let's head back over to the creatures list view and use the changes we just made. Now I no longer need this creature array that had the placeholder data, so I'm going to highlight and delete this. And I'm also going to highlight and delete this text. I don't need this anymore. And I'm going to highlight my entire list with its two modifiers and command / so that this is now uncommented. And now let's make some modifications. First of all, we want to get at the array of creatures. So the way that we do that is right here, the first variable inside of the list parentheses, we're going to say creatures.creaturesArray. Now we'll still call each individual element a creature, but then down here in text, we want to get creature.name. And here we've got one more error that we need to address. Again, very common when working with SwiftUI. This says we're not conforming to something called hashable. For now, all we need to know is that conformance to hashable is necessary for an array that we want to iterate over, like we're doing in this list. But all we need to do to conform to that is to head back to creatures view model, and in our results struct right after we conform to Codable, we'll add comma, hashable, error fixed. We'll head back to Creatures List View and look it over here at the live preview. Jumpin' Jigglypuffs, Professor Oak. We've got a whole list of Pokemon in here. We didn't type those in. They came from the API call JSON successfully parsed. So this looks dynamite. API call done. JSON parsing mastered. Another ultra awesome skill in your tool belt, Swifter. But we're going to learn a lot more as we continue to build out this app. So stay tuned for the next lesson and continue to hack.